Welcome to dividing polynomials using long division. With polynomials, you can obviously multiply, add, and subtract, and here we're going to divide using long division. So on the left-hand side of the screen, you see the regular numerical long division that we did on, third, second grade, fourth grade, and so on, where we're dividing how many times does a number go into another, multiply, then subtract. Same concept with polynomials. You're going to be multiplying and subtracting. So with the key here, if you have a binomial, and we're going to see how many times does this binomial go into a trinomial, you will always start above the linear term. I like to say that, okay, we're dividing by two terms. That means we're starting above the second term of whatever we're dividing into. So if we had four terms, we'd still be dividing and starting above the second term. I'll give you an example in the third slide of this video. So we want to divide using polynomial long division. So we want to know how many times does x plus 5 go into 4x squared plus 23x minus 16. We want to know what is the quotient and the remainder. The quotient is what's up top, and remainder is going to be obviously what's left over. So here we're starting above the linear term because we are dividing by a binomial. Because we have a binomial, we're going to start right here. So key for long division, we're going to have 4x squared here because we need 0. Because again, we're subtracting. So what times x will give us 4x squared? So the only thing that will give us 4x squared is 4x. Then we multiply. 4x times x is 4x squared. 4x times positive 5 is positive 20x. Now, you need to remember subtracting polynomials. We have a polynomial of 4x squared plus 23x minus 4x squared plus 20. So a minus times a positive makes this minus a negative. So 23 minus 20 will give us 3x. And again, remember to drop down the negative 16. So this is going to be 3x. And remember, we're subtracting. So what times x gives us 3x? Here, it's going to be positive 3. So 3 times x is 3x, 3 times 5 is 15. And this is going to be positive 15. So 3x minus 3x gives us 0. Negative 16 minus positive 15, minus times a positive will become a negative, so it's negative 16 plus negative 15 will give us negative 31. And we're going to stop because this is x to the 0 power, and the x to the 0 power is always 1, and we are 1 less than what we're dividing by, our degree up top. Since we're having a first degree polynomial right here, we stop when we're 1 less than the degree. But you don't put x to the 0. So since we didn't get 0, this is our remainder. So we're going to have 4x plus 3 with a remainder of negative 31. More precisely, it's 4x plus 3 minus 31 over x plus 5. Since the remainder is not equal to 0, 4x plus 3 is not a linear factor. Either is x plus 5. So in other words, we have a remainder Therefore, x plus 5 is not a linear factor. That means x plus 5 cannot go into 4x squared plus 23x minus 16 evenly. Let's go on to example 2. So how many times does x minus 7 go into 3x squared minus 29x plus 56? So let's find out. We have x minus 7. 3x squared minus 29x plus 56. Since we have dividing by two terms, we're going to start above the 29. This has to be 3x squared. So here's my box. What times x gives us 3x? The only thing squared is going to be 3x. So 3x times x is 3x squared. 3x times negative 7 is negative 21x. And we subtract. And we get 0. And we have negative 29 plus 21 will give us negative 8x. Drop down to 56. Now we have to know, okay, we have negative 8x. What times x gives us negative 8x? It will be negative 8. So, negative 8 times x is negative 8x. Negative 8 times negative 7 is positive 56. And again, we are subtracting. So negative 8 minus the negative 8 becomes positive, which becomes 0. 56 minus 56 becomes 0. So we have no remainders. So no remainder means x minus 7 is a linear factor of 3x squared minus 29x plus 56. One way to check this out is multiplying. So we have x minus 7 times 3x minus 8. Does it equal 3x squared minus 29x plus 56? And that is true. Here's example 2 where you need to fill in missing terms. So how many times does x squared plus 1 go into 3x to the 4th minus 4x third plus 12x squared plus 5? Notice we have to add in the linear term in both polynomials, because when you're dividing, you need every term from highest degree down to 0. In other words, if we have x squared, we need x to the first. Since we have x4, we need 3, 2, 1, and x is 5 is really x to the 0. So you got to remember, your highest degree down to 0. So if you have x to the 5th plus 1, you'd have to rewrite it as x to the 5th plus 0x to the 4th, 0x third, 0x squared, 0x plus 1. Because you need every single degree in between 0 and your highest degree. So since we have 3, we're dividing by a trinomial. That means we have to start above the third term. So this has to be 3x to the 4th. What times x squared gives us 3x to the 4th? This will be 3x squared. 3x squared times x squared gives us 3x to the 4th. 3x squared times 0 is 0x to the 3rd. 3x squared times 1 is going to be positive 3x squared. And again, you are subtracting. So when you subtract, you have 0, x to the 4th, which is 0, minus a 0 gives us negative 4x to the 3rd, and then you have positive 9x squared, because 12 minus 3 gives us 9. And again, we have to bring down the 0, x. So now, what times x squared gives us negative 4x to the 3rd? So this would be minus 4x. So minus 4x times x squared gives us negative 4x to the 3rd. Negative 4x times 0 is 0x squared. Negative 4 times 1 is negative 4x. And again, we subtract, which means this turns to a positive, negative, positive. So we have 0. 9 minus 0 is 9x squared plus 4x, and we have to drop down the 5, positive 5. So now we have to see 9x squared. So we have positive 9. 9 times x squared gives us 9x squared. 9 times 0 is 0x, and plus 9. And again, we are subtracting, which means you have to switch your signs. So next, 9x squared minus 9x squared is going to be 0. We have 4x minus 0 is, again, 4x. And 5 minus 9 is negative 4. And we stop. The reason why we stop, because we have x to the 1st, which is less than x squared. So we stop. So, did we get a remainder of 0? No. Therefore, x squared plus 1 is not a factor of 3x to the 4th minus 4x cubed plus 12x plus 5. So our answer, you can rewrite it as 3x squared minus 4x plus 9 with a remainder of 4x minus 4. Or 3x squared minus 4x plus 9 plus 4x minus 4 all over x squared plus 1. That is long division. If you have any questions, please give me a call after school or before school or lunchtime.